Helpers and debugging tips. Using light helpers to track down shadow problems. Real-time shadows are a great feature in Three.js, but they're also the source of lots of head scratching. 1 minute your shadow is looking great, the next it disappears. In this video we're going to look at how you can better understand shadows and how to use helpers to track down shadow problems. Take a look at TTT 2.1 stars at this address. Here is a fairly simple scene. I've added a keyboard listener, so if you click on the 3D view, then press the WASD keys, the weird yellow avatar will move around. Notice that if you move too far, the shadow disappears. Why? Before we answer that question, let's add a helper. Enter helper equals new 3 dot directional light helper light scene.add helper. All you get is a strange white line added to the view. Click on the camera button and the camera switches to a different view. Now you can see a plane where the light is located and a white line extending from the plane to the avatar. Click again to get an overhead view. If you move the avatar, the line stays fixed. A directional light helper can be useful, but if you want to track down shadow problems, you really need a camera helper. A light that casts a shadow will have cast shadow set to true. This means that the shadow property will contain a directional light shadow class. If you look at the Three.js documentation, you'll see that this class contains an orthographic camera. A shadow is created by a special render engine from a camera location. Let's change the helper. Edit the helper line to helper equals new 3 dot camera helper light.shadow.camera. Now, in addition to the white line, a yellow line shows the frustum of the camera. Any shadow you see cast onto the plane will be inside this frustum. If you use the W key to move the avatar, you can see, probably best from the overhead view, that where the shadow disappears is when the avatar crosses the boundary of this frustum. So how can we fix this? 1. Make the frustum bigger. We know from the docs that the left and bottom are set to -5 and right and top to 5. Near is 0.5 and far 500. As ever, we want the frustum to be as small as possible. 2. Set the light target to the player character. 3. Move the light with the player. Let's try number 1. Add const size equals 10. Light.shadow.camera.left equals -size. Light.shadow.camera.bottom equals -size. Light.shadow.camera.right equals size. Light.shadow.camera.top equals size. Light.shadow.camera.near equals 1. Light.shadow.camera.far equals 50. Notice how the shadow is starting to become a little pixelated. Change size to 4. That's much better, but it doesn't fix the problem with the avatar moving outside the shadow camera region. After creating the player, add light.target equals player. Now the light points at the player, but that means the direction of the light changes, and that's not the effect of a directional light, which is like the sun, so far away that a movement of the avatar shouldn't affect the light direction. We need to do fix number 3. Add a new global variable, light offset. After creating the light and setting its position, add light offset equals light position clone. This will work only if the original position of the target is the world origin, 0, 0, 0. If the original position of your target is not there, then add light offset.copy light position.sub player position. This ensures that the light offset is the offset of the light from the target position. Now, in the update method, use this new value to position the light. Enter light.position.copy player position.add light offset. Using the WASD keys allows you to roam around the environment and the shadow will never leave the avatar. Great work! Notice that in the update method we use helper.update as long as the helper is not undefined. This is essential if the transform matrix of the helper changes. Since the camera is moving with the light, this is necessary. You could be wondering why not simply add the light as a child of the player. Good question. The reason is the light would then rotate with the avatar. By so doing, the light direction would change, something we need to avoid for a directional light, but it might be a useful solution in some instances. You can see that helpers help to visualize what the renderer is going to render.